Lab 7. This is the continuation of the previous lab. We have taken 3 videos. One-dimensional, we have a free drop of a ball, and two-dimensional, we have a tennis ball, and the so-called three-dimensional, we have an airplane just randomly thrown in the air. We have 3 videos. In this lab, we will load this video into the LoggerPro to analyze it. Okay, and we will analyze this video one by one by loading them into the LoggerPro. We will first trace the trajectories by using the add points and to obtain the motion diagram first, and then we'll sample a few data points to calculate one velocity at one point manually. And of course, the LoggerPro also will compare its result. But LoggerPro gets all the data. Finally, we will store all the data. That part you will learn this time and for the future use. We'll repeat the following step for each video. Repeat the procedure for one dimension to one by one. Okay, you do one, and for another one, and for another one. First you load the video into LoggerPro and trace it to get the motion diagram. Those blue dots form a motion diagram because the video plays at equal interval of equal time, so it is a motion diagram. However, I want you to sketch the videogram by hand, put them side to side, and do some analyze with it. For example, this is how you trace the tennis ball. And we'll do this, and of course you will set scales. This is nice. You can see that they are not uniform. It is actually two-dimensional projectile motion, and we will do this. Okay, see it's going faster and faster. So that's okay. That's enough, you just put this back in. So that is actually your motion diagram. Of course, to get this, you have to have the scales, coordinates, as we talked about in previous lab. So now I have my motion diagram. Now you will cut your motion diagram, and you don't have to have the full picture. So that's what the lab is for. So that's coordinates. That's my motion diagram made by the tool. So then I will paste that into my lab. Now I paste that into here, so see, and I will adjust a little bit. Now just paste the thing here, not just pasting here. I want you to sketch the motion diagram on the side with your by hand. You don't have to make it perfect, but you have to have a correct scale. It's like here, if you use this, so at the in my case over here is 0, that will be this point, and then it go up to here, and then you can use this to measure. So this pointer, once you have the scale into the LoggerPro, you can measure it. So over here, so you see on the far left is 1.31, okay, 1.31, and then so here is 1.31 at 0. At the top it is just in the middle, 0.6867, and that's this point, and then and top 1.2, that's 1.2 with this scale, and of course here is 0, and then you don't really have to make it, but you have to sketch, put this characteristic point here, and then I want you to mark where it has maximum speed, where it has lowest speed. So so I'm doing it just as if I'm a student. I'm doing it here. You can just do with your pencil, carefully draw the picture. Important to put the scales, get the scales from here. Now I'm trying to complete this one, and so here. And then, yeah, I want you to draw with the pencil, things like that. Mine is not perfect, but I try to do this. Important to get all this scale from that. Basically, that's your motion diagram. The next step, and using the data generated by LoggerPro, and LoggerPro will produce all the coordinates, all the velocities, and all the accelerations in x direction and y direction. Well, here the second step, I want you to calculate, just sample one point, do your own calculation, see if it agree with the LoggerPro calculation. That means LoggerPro is doing a good job. In my case, I sample this point from here, initial time 1.100 and to final time 1.113, and initial position and final position. And then they use this to calculate the velocities using the formula we talked about in the class. And they end up with the final velocity being this. So you just copy this data, and so that's time. And so these, and copy. Example from here, 1.100 and 1.133, and the tennis ball traveled from here to here. It's going in the negative direction, and use the initial time and final time, initial position and final position, and calculate the velocity to be negative 1.715. I just want to see if it is indeed this. So in that case, then copy the data and paste right here. You take the data from the LoggerPro, and as if you don't know the answer, you calculate the velocity of this point, basically initial velocity, initial time, initial final time, and initial position, final position, and you take this data here and you do this calculation for the velocity. In fact, the velocity turned out to be negative. In my case, a tennis ball going to the negative direction. You see the velocity here, I got exactly 1.715. See the LoggerPro, and got exactly 1.175. So now you know what LoggerPro is doing. Of course, it does all this for you. Now, for x direction, also y direction, it just point by point get all this calculation done. I need to find out where the object travel the fastest and the slowest on the trajectory, on the path, and mark them on the motion diagram. You can either do this by just looking at the motion diagram, or by examining the velocity data table and x, vx, y. For example, look at just by examining the motion diagram for this tennis. You see, remember, motion diagram was taken by equal time interval. In this particular example, at the same time. So let's see that one. When the dots are farther apart, that just means faster. When it's close together, because take pictures, it's not moving that much, and it's slow. From here, you can see that it's going very fast when you go up, and then it slows down, and of course on the top, but it's still going. It's not zero, but that's speed, and then speeding up. So I would say here is the fastest, here is the slowest. No, on the top is the slowest, but it's still moving. You can also find out where the object was fast by looking at the velocity, but in this case it's two-dimension. So what we will talk about in class, actually overall velocity is the square and square root of the square of the velocity, but still you can see if the bigger numbers, both of them will be bigger. So see, these are velocities and y velocities. So y velocities is to go, the velocity in the right direction, start very big, which means going fast, and then going up and slow down, almost zero, but not exactly zero, and then changing the direction, which means it's going down in x direction, and then it will continuously going in a negative direction. So when it's biggest, when these two numbers are biggest, when the star is big, you see, and then this number getting small, but on x direction not changing much. So the slowest is on the top over here, about 1.5 seconds over here, and then you're getting faster again down here. If you see down here, it's getting faster. So the result for this parallel is on the top is slow, on the bottom, on the top is slow on either side. When you come back or when you start going up, it's fast. So in this case, now that we have have the motion diagram. We're almost done. But the last step is to store the data for next lab. We're going to do more detailed analysis of these motions in 2-dimension and even 3-dimension, but we're not going to use LoggerPro, but the data we just use a table. So if you highlight now the fourth step, the fourth step is to highlight this thing, and here is LoggerPro, and you export the data, export Earth, and save it as CVS. It's called as common separated variables. That's a very well-known formula used by Excel. So basically this data chart become the Excel files, and then you can have a file saved like that. So I already disabled it, I cannot show you, but once you save that, you give it a name like this. Then you will see a file named this. You see file like named, so tennis, if you start this, you see the data, velocity data, and velocity and all these to save this format, and then we will use this new software, Excel. I think those of you who major in business or computer science, I'm very familiar with this. We're going to analyze the data with Excel. All right, so that's the first step, and then you repeat this for next object. Final step is to export and store the data for next lab future use. Just highlight the data table on the LoggerPro, and you will do LoggerPro file and export Earth. Hopefully you're familiar with my notation. Whenever you keep on going with pull down menu on the computer, this from LoggerPro, go to file, go to export as, and go to CSV, which is common separated variables. That's a very popular format for the Excel software. And this created file, we're going to store this file for next lab. We name it. And now once you are done, you'll repeat for next object. So you do 1-dimensional video, 2-dimensional video, and all 3 is done. And then I have several questions for you to answer, and that's it.